Hi, and welcome to today's AWS Fireside Chat, how Amazon.com broke free from Oracle. I'm your host today, Doug Flora, and I'm joined by Thomas Park, who is Senior Manager of Software Development for Amazon.com. Welcome, Thomas.
Thank you.
And so before we dive into today's topic, just tell us a little bit about yourself. How long have you been at Amazon, and what are you working on now?
Sure. So I joined Amazon about 8 years ago, first with AWS and led a team there in Virginia. And then I had an opportunity to move to Korea to lead a team there before I came and joined e-commerce foundation services team. The team is actually providing a lot of foundational services for e-commerce business, and I am a software development engineering team lead there.
Got it. And you're joining us today on this topic because you played a very direct role in the massive migration that Amazon.com recently completed, actually, off of Oracle databases and over to AWS services. Databases, but also there's an analytics and data lake side to the story that we'll also get into. Could you tell us a little bit about how that actually, before we get into your role in it, how did that project begin? Because it was a multi-years process. What made Amazon embark on this journey to get off of traditional Oracle databases and go over to the AWS services?
Sure. I joined Amazon in 2012, and when I was working with a number of different customers as an SA manager, many of the customers were wondering about how to migrate database into AWS. Fact of the matter was, I did not have any experience prior to joining AWS. So I really was looking for an opportunity to actually take on a project where I can actually do it and have a hands-on experience. And that time actually came around 2016. At that time, I learned about this particular project to migrate not only OLTP databases, but also the biggest data warehouse that Amazon.com had. And I said to myself, this is a perfect opportunity to take on this project. After I joined, around July of 2016, I learned about the origins and the reason why we had to move. And number one reason that I heard was in 2015, we had our own very first Prime Day. And unlike the Black Friday or the peak that usually happen around Thanksgiving, this Prime Day happened in the middle of the year, which was July. And which means a lot of operations and preparation, we actually had to do it much, much earlier than what we used to do. In fact, it was so successful in 2015 that we had to process close to 34 million orders. And obviously, that number started to grow. And to the point where we were gaining a lot more data in our database infrastructure. So the cost of operating those databases continued to grow, as well as the complexity of database software license also gotten worse. And the number of databases also grew at the same time. And we were running into a lot of issues like operational issues, outages, as well as free disk space. We just could not store enough information into our database infrastructure fast enough for us to grow.
Got it. Yeah, I think this reflects what a lot of our customers have experienced as they grow on AWS, as their applications gain more users, as they run into huge traffic spikes during events, popular times of the year. It puts more and more strain on their database infrastructure, and that's why they look to moving to manage database services like RDS, DynamoDB, Amazon Aurora. So tell us a bit about, as Amazon started facing these challenges with the first Prime Day and onward, hitting record peak traffic as well as just increasing volumes, petabytes of data to manage. How did the different teams within Amazon, decide how to tackle these issues? AWS had some database services like Dynamo and RDS. What was the starting point for Amazon in deciding which database service do we move to? How are we going to re-architect these applications to run on managed databases?
So around Amazon's been around for 1995. We actually opened our door to the world. And back then, the architecture was fairly simple. We had a simple web application backed by centralized database. And those two systems were processing all the orders, and they will handle shipment as well as payment. And as more and more people order more orders and items online, that monolithic system started to break down. And we started to break down our application into service-oriented architecture way back. And to the point where we were able to scale independently the service application side and database side. One of the problems that we had was the database itself, the infrastructure as well as the architecture hasn't changed since we actually launched our Amazon.com. We were still using relational database. And a lot of teams struggle with actually learning about the new technology. And when you actually don't have to migrate or adopt new databases or technologies, people just simply do not have a necessary skill set or experience. So I actually, in a meeting one time, asked the engineers, how many people actually migrate database or have involved in a project like that? I believe only one or two people raised their hand out of 100. And then I knew right away that we are going to run into a lot of challenges. So one of the strategies that we actually implemented as soon as we took over the program was to creating a lot of reference architectures, best practices, training sessions, as well as identifying those people who are very much interested in adapting new technologies. And we gave them a lot of tools and speaking opportunities. And we also work very closely with AWS team, their solutions architecture team, their product team, did a lot of sessions and talked to our engineers, talk about different data models, data structure, technologies, and some of the challenges they will face as they take on this journey so that they are mentally prepared as well as technically prepared.
Got it. And building off of that, you mentioned Amazon was continuing to run almost entirely on traditional relational databases. So you think of Oracle is primarily what Amazon.com was running on. Other examples would be SQL Server. Moving over to something like DynamoDB, which is just a fundamentally different type of database. It's a non-relational database. It's a key value store. It's not just a matter of retraining teams on a new technology. It's the applications themselves would need to be massively overhauled and re-architected. How did teams go about starting that process?
So the biggest challenges that we had with the relational database was scalability and latency issue. There was a lot of back-end process the relational database had to do in order to keep the data stored in the database. Our applications, especially when we are running into a lot of transactions and data volume, we wanted to re-architect it and redesign our data structure and technology so that we can actually process the data quickly. And NoSQL database by far was the best choice for us. We're not saying that every transaction is fit for NoSQL, but there are certain transactions that are far more better to leverage NoSQL than relational database. The fact of the matter is AWS database service offers not only the NoSQL database solution, but also the relational database solutions. In fact, right after I took over the program in late 2016, in fact, I believe it was 2016 reInvent, AWS announced Aurora Postgres. That was a game changer for us. That announcement allowed us to think about other options than NoSQL. There were a lot of non-critical databases. There were on relational databases. In fact, there were some applications that still needed to be on relational databases. But the fact that the Aurora Postgres was launched in 2016 and allow us to look at the technology and gave us an opportunity to review all the options and allow the teams to pick and choose the right solution really changed the program in different direction.
Right, and for those viewers who aren't aware, Amazon Aurora is our own relational database. It's available on Amazon Relational Database Service as one of the engines that you can run. It's MySQL and Postgres compatible, but really we built it from the storage layer up to be a relational database for cloud workloads, for internet scale. And so that gave you a relational option for those workloads, those transactional workloads that needed to stay on an RDBMS. Could you tell us more about that choosing process for, AWS has 14 plus now different database engines available as managed services. You brought some applications to Dynamo, some to Aurora, some to Redshift, our data warehouse service. Were there some patterns, some general patterns that teams followed to decide, is this gonna go to NoSQL and we're gonna re-architect for NoSQL, or can we lift and shift this to Aurora Postgres?
Sure. A lot of critical services that require low latency and high transactions, our recommendation was to take a look at the NoSQL solutions because of the scalability limitation of relational database. Obviously Oracle, the legacy Oracle database, we tried to scale as much as we can vertically as well as horizontally. And one of the biggest Oracle database fleet that I was managing had close to 60 different shard method with multiple partition options. We also had Oracle RAC clusters in our data warehouse. We were operating close to 100,000 partition operations, adding and deleting on a weekly basis. All that maintenance work was impossible for us to sustain our transactions. So knowing a large amount of transactions that Amazon.com had to process, we knew for those critical services that require low latency, high volume transaction, we wanted to take a look at the NoSQL as an option. For those transactions that require very high data consistency, as well as the integrity of the relationship, it was an obvious choice for us to look at the relational database option, whether it was a Postgres or MySQL. There are options for us to look at that particular workload or data patterns and then easily transport into Aurora Postgres using the services like DMS. And we kind of guide these teams. And we actually also created decision metrics. So for those teams who are not familiar with all the AWS database options, we created there are options for you to choose Elastic Cache. There are options for you to look at NoSQL like DynamoDB, but also RDS and Aurora with a different database engine. Whatever they may be, it will fit it into your workload or should be able to handle your business. We wanted people to actually look at those criteria and be able to make their decision and try out different options. So the creating that decision metrics for the teams who are not familiar with database options actually helped a lot too.
Got it. Yeah, that sounds like, there's a process where Amazon.com was learning and then also working back with AWS service teams to kind of build out these best practices. And you mentioned tools like DMS, database migration service, was a huge part of the migration success. So could you tell us a little bit more, in working and collaborating with AWS on these migrations, how did that contribute to building out of tools and resources that customers can also use as they go on their journeys to migrate off of legacy databases and onto AWS?
Right. So initially, we were really focusing on those transactions or applications that had very high volume, and we with a whole bunch of scalability issue, and we were trying very hard to migrate them over to a different type of database technology for us to meet the business. Later on, we learned about DMS and Schema conversion tool, which is part of that whole suite of solution. SCT actually allow us to look at every single database schema and determine whether or not this particular database migration will take 2 months versus 12 months. Because it allows you to take a look at the schema and evaluate how much of those schema or the functions or the very specific Oracle features can be converted into a target database. In our case, Postgres was a main target just because it had a very similar feature function set, as well as the power of Aurora allow us to scale our business without really changing the data model. So working with the SCT team, what we actually ended up doing was running that tool in command line. When we actually start migrating, they didn't have that version. So we actually created our own version and tried to run it against thousands of Oracle databases using GUI, just didn't scale for us. So one of our engineers actually took that code and create a command line, and we start running that tool against entire fleet of our Oracle databases. And then we did a t-shirt sizing of these databases and say, this type of database will take us X amount of time, and we label them as extra large and extra large and large and medium and t-shirt sizing pretty much. And then we started to looking at the dependencies of these databases. Sometimes the database cannot just migrate by itself because it's integrated with other databases, other applications, other jobs. So we also had to draw up all the dependencies of these databases, database schemas, who was using what tables, as well as application dependency. And once we did that, we realized we cannot just organize this in a spreadsheet. So we actually created our own tool to map out all the conversion, t-shirt sizing, as well as dependencies into a tool where the software engineers can easily go and take a look at their database usage and dependencies. This kind of gave a huge visibility into what they had to do in order to migrate the database. It also gave them an opportunity for them to plan ahead and mitigate some of the risk. Good example is we had a number of data warehouse jobs running on these OLTP databases for extraction. Sometimes these jobs were not necessarily, nobody was using that job. And why not just kill or shut down those jobs? So we also work with teams to identify those waste, whether it's a processing job or the data, archive them, clean that up before they start migrating to new databases. So leveraging both AWS tools like SCT and DMS, as well as our own tool, allow the teams to really looking at the database migration as a project they can actually take on and then manage that risk.
Yeah, and so when thinking about those, those best practices and those models that these many different teams within Amazon could follow, the scale of this project was huge. By the way, I mean it was nearly 7,500 Oracle databases. That was the Oracle footprint. 75 petabytes of data across hundreds of teams. Managing customer-facing services like Amazon.com, the e-commerce site, Prime Video, Alexa, so on and so forth. How did we manage culturally? We talked a little bit about from blueprints for re-architecting or for choosing the right database. But what about culturally? Because many of these teams had teams of database administrators trained on a specific technology like Oracle. They had a way of doing things, a specific skill set. How did we tackle, hey, we have to train employees on new skills, we have to change the mindset of the database, not just the technology, but also we're moving from self-managed databases to managed database services on AWS. So that changes how you think about your job role, your priorities, what you spend time on.
Right. Like I say, I joined the team to take on this migration project in 2016, thinking that this was the biggest Oracle database migration project in the world. For me, it was a very exciting opportunity. I made an assumption that everybody actually was thinking like that, and that was a huge mistake, which I learned. I told the team, because when I first joined and take on this migration, I also had a responsibility of managing and operating over 2,000 OLTP databases, as well as the data warehouse system, which consists of 27 clusters, 635 nodes, over 50 petabytes of data. It was processing over 600,000 jobs a day. It was a massive, massive system. And my job was not only migrate all these data and databases, but keep the light on. And not only keep the light on, but be prepared to process the next big event. Because we were having Prime Day, Black Friday, and then another Prime Day. So twice a year, we had a huge event that we had to prepare. And instead of having 10 months to prepare for one event, we only had 3-4 months to prepare for the next event. And as I mentioned before, we were growing. Our system had to process so many orders. And each event we had to forecast. The forecast will increase 3, 4, 5 times. Every time we look at the number, we're like, how in the world are we going to make this? At the same time, how are we going to migrate all these databases? And some people actually told me, you should go ask for 1,000 people to do this migration. I did not take that route because I thought that having a dedicated team to migrate all these databases and something goes wrong, everybody's gonna just point a finger at that team. This migration had to be done by the business owners, the system owners, the service owners, those people who are responsible, who actually understand the service and application, are the ones who have to take ownership and take migration. And the way that I looked at it was also, I had to tell the Oracle DBAs, those people who actually were maintaining the legacy system, that we are going to get off of Oracle. And surprisingly, a lot of people did not take that news that well. In fact, about 10% of my DBAs actually quit after I announced that we're going to actually migrate off of Oracle. And initially, I did not know why. Later, I found that out from talking to them, that they felt their career was over. They did not really see it as a career advancement to do this migration. Why participate on a migration where their entire career was built on Oracle technologies? I did not understand that part, and I had to address that part quickly because I couldn't afford to lose any of them. because I still needed to process and maintain the Oracle databases for the next Prime and Black Friday. So I quickly create this career path for the Oracle DBAs. I told them, because of your legacy Oracle database knowledge, you're going to also learn about new AWS cloud technologies. You're going to be the bridge. You're the one who's going to actually demonstrate, because of your knowledge on the legacy and new, people are going to look at you as an expert who can help them cross that big migration. Mm-hmm. You're the one who's going to tell us what kind of database migration risk exists in the legacy system. And then once the migration is done, you're going to help thousands of other AWS customers to do the same thing. Obviously, not everybody took that offer, but vast majority of people actually understood, because they also knew that their career had to change and evolve. Mm-hmm. And giving them that hope, and I was there to help them, I think changed their heart and changed their mind. And once I got their support, the migration went into a place where they wanted to migrate. They were coming up with ideas how to mitigate, how to migrate, how to convert some of the legacy code into the new. And they were very excited about new AWS technology. In fact, one of the project that one of my database engineer did was identifying the dependencies of Oracle database by looking at the connection log. If you take a look at the Oracle database, it actually has a lot of tables and is used by many different service owners. The question actually came, who's the owner of migrating this database? Is the creator of the database, creator of the table, or users of the table, or the DBA? The ownership model wasn't really clear because it was an infrastructure where everybody just used and expect to be running. So one of the engineers actually came up with this idea, hey, why don't we just take a look at the connection log, parse all that information through AWS EMR, put that into a graph database so that people can see the diagram of who's connecting into database and how often. And he did that over the weekend. And when we actually demonstrate that whole diagram to other DBAs, everybody was blown away. They were like, you know what? I used to do just Oracle database. Now I can go out into the AWS and actually using Python, parse all the listener.log from Oracle servers, process EMR, which is part of the big data technology solution that everybody was talking about, and they were actually learning hands-on with and trying to solve the real business problem. And then they showcased that to engineers, and everybody at that day, I still remember there was a January 2017. I think people started to see it differently. They really thought that their career, their job can change and they can evolve to something different. So culturally, it was extremely important for us to get Oracle DBA support and get their blessing and get them on board because they play a critical role in our migration.
Yeah, and this gets into, as DBAs or any number of other roles start to learn and embrace the world of purpose-built, we like to use the term purpose-built databases because you have, it's not just, there's not just one type of NoSQL database like Dynamo. You mentioned graph databases. We have Neptune, a graph database. We have a ledger database, QLDB. So there's this whole world of non-relational databases that are purpose-built for different workloads, and this opens up all these new opportunities, like you mentioned. And so, and that in turn makes teams more productive, not just because they can spend time on other tasks, but because the databases become more productive for the team, for the business outcome.
That's
right?
absolutely right.
Yeah.
When I first joined the team to assess the teams where they were spending their time, vast majority of the DBAs were spending their time provisioning new hardware, applying patches, and then process. I mean, just be prepared for the big event, the capacity. Putting all the backup servers, standby servers, spare servers, asking hardware engineers to get the necessary parts into the right regions and data centers. And obviously, we had different types of database servers over the years we accumulated. So try to prepare for an event really require a whole bunch of unnecessary operation burden on the DBAs. And I believe the number was close to 80 to 90% of their time was spent on those hardware provisioning and patching and capacity planning.
Yeah, and so thinking about those are kind of the benefits for the individual or the team. Thinking enterprise-wide, since we announced recently that the final Amazon.com Oracle database was shut down. We've completed this migration. What are some of the initial business benefits that we've seen across the company, including any interesting team level examples that you can think of?
I would say there are both tangible and intangible benefits that I personally experienced and we experienced. Tangible experience or benefit obviously was we no longer have to spend our time provisioning, patching, and thinking about the capacity. We don't have to actually stay up late at night thinking, are we going to be able to, do we have enough capacity to meet the demand in the next big event? So that's automatic 80 to 90% of our time, the DBA's time or operation time that we no longer have to do it because we are relying on now managed database services. Latency and availability and scalability improved significantly. We were seeing across the board close to 40% latency improvement after we migrated to database such as DynamoDB. We can provision at will and create instant capacity incremental to meet our demand. So time to react, time to market definitely improved. There are other benefits. For example, preparation time. Like I say, our job was to prepare our team to process the peak event. Amount of time it takes for us to prepare literally went down close to 50%. We no longer have to think about how to provision hardware. We can simply dial up or dial down in order to meet the demand. There are also intangible benefits that I see. One is the people side. I think a lot of engineers now know so much about database and database infrastructure, and they have a huge confidence about how they can actually move and choose the data storage layer. I talked about how people did not have any experience. In fact, not a whole lot of enterprise will have a whole bunch of people who actually migrated number of databases in their career. You don't actually think about migrating to different database engine. You always think about implementing new service into new database engine. We now have thousands of software engineers who not only understand how to pick and choose the right database engine to scale our business and meet the demand, but they also understand the legacy code, which is huge. We had over the years, so 25 years since we launched our virtual door to the world. Since 1995, we accumulated huge amount of technical debt as well. Through this migration, every single team who has ownership on the database migration, they look at their code, they test their code, they optimize their code, they reduce the number of data they had to migrate it. Now we are so much lean and we can go so much faster, and there are so many internal knowledge and experience within our team that we can literally take on additional challenge that the business require us to do. From that perspective, I think it's really hard to put a number around it, but I think there's a huge benefit to us.
Yeah, and so Amazon.com, obviously an enormous company, but you've touched on how a lot of these challenges were tackled by small teams, in some cases kind of scrappy teams, figuring this out from the ground up, but also partnering with AWS service teams and solution architects to navigate through these challenges. And we have customers of all sizes who are making very similar transitions right now off of old guard databases like Oracle, like SQL Server. We've actually migrated more than 180,000 databases using our database migration service, DMS, that you've talked about quite a bit. Of course, we still have customers coming to us all the time. How do we get started? We have this huge footprint of traditional relational databases on-prem, commercial licenses. How do we get off? Customers need to learn not just NoSQL, also open source. If they want to move to Aurora, it's about embracing MySQL and Postgres compatible database systems. So where should customers start? If they're kind of scratching their heads or just getting started on this journey, what's the best place for them to start?
I think that the very first place you should start is, why do you want to migrate? I think that was very important for us. I mean, we had a very clear vision and the motivation to migrate off of Oracle. We were running into scalability and availability issue. Our business was growing and the data volume was growing. We couldn't just sustain with the existing infrastructure. A lot of companies may have the same motivation or different motivation, but clearly understanding the motivation, why you want to migrate your database, I think is the first step. Once you have the vision and the motivation, and I think it's important to get buy-in from both your top executives as well as your DBAs and bottom up. Without that support from top and bottom, it's going to be a much, much harder journey than getting their support and buy-in. Third thing I think is important to remember is just do it, right? You don't actually have to migrate a production, most critical system in your company over the weekend and cut over. That's not what I'm talking about. I'm talking about just take one or two databases using a tool like DMS and SCT and actually do it. You may not succeed and fail, but you're gonna learn so much from that journey. In fact, that's exactly what I did. I asked 5 top engineers to pick randomly selected database out of 2,000. And I gave them 1 week to go and migrate using DMS and SCT. And they all came back, and none of them actually couldn't do it, but they all came back with their lessons learned and what they learned. And the first thing they said was there was a network issue. And all 5 of them say, yeah, there was a network issue. So I realized that that's the number one thing that I have to tackle, right? So just doing it, you may not be successful first time, but you're gonna learn so much about your legacy. You're gonna learn so much about your technical debt. You're gonna learn so much about your culture. You're gonna learn so much about how the actual database system actually operate. We didn't even know how many databases we were running when we first started. The visibility wasn't there. So, once you have the motivation and vision, and you have to gain support from executive and DBA, the third thing is just do it, and then make sure that you continue to increase the visibility of your database infrastructure. Remember, database, most of the enterprise, and including Amazon.com, we didn't touch the infrastructure for over 25 years when we first launched our website. So there are a lot of technical debt, a lot of process that is embedded in your company. And more you shine light on that infrastructure, I think better you will be, because then you can actually plan your database migration. You can actually set right expectation. You're gonna be able to find the right people to work on the migration. and give ownership to the right team and right individual. So visibility, understanding all the connectivity, dependencies of the database, understanding the table usage patterns, understanding the application dependencies, who's using what database for what purpose, how many read or write operations are happening inside of the database, for what reason. And these type of visibility will allow you to remove waste even before you start migrating a single database. In fact, on average, we optimize our database. About 30% of our database usages that we evaluated was complete waste. It was just unnecessary jobs, unnecessary queries, the tables that nobody used, but we were replicating across multiple databases and using up all these resources. There were huge amount of old data that nobody really cared. We were able to identify those. And that was before we even start the whole migration progress. So, looking at your old legacy Oracle database, whether you are ready to adopt AWS technology, I think it's just best practice to do that. Once you understand that, and I think is working with AWS teams, working with AWS product team to ensure that you have a good relationship. Because you're going to run into some challenges and you are going to run into some barriers because of your unique business case or technical requirements. And having good relationship with AWS will allow you to not only understand how to overcome those barriers, but also gain some insightful information about different workarounds and solutions. Because when we start the whole process and we realized that there were a lot of early adopters who were willing to migrate, they were willing to tolerate, and they were willing to look for different areas to work around the technical barriers. Those are the ones who actually came up with very innovative informations and solutions. And we share all that information back to AWS. I'll give you a good example. I talked about conversion rate of SCT when we first started. It was actually below 50%. So when we actually ran against our 2,000 Oracle databases that my team owned, and obviously we had a lot more, and we did a t-shirt sizing, only 50% of our databases were able to convert it into Postgres. And we gave a whole bunch of feedback to DMS and SC team. By the time we were almost done with our migration, that conversion rate increased to close to 90%.
Wow.
So that, we went through a lot of workarounds, and our engineers were able to come up with the different ideas. And we shared that with AWS, and AWS actually implemented those changes into SCT and DMS so that other AWS customers do not have to go through. And sharing that challenge and sharing that workaround really accelerate our ability to migrate databases much faster and create that tipping point for us.
That's great. And I think, and our other customers will hopefully experience the same thing, that they can engage at a level with our service teams and SAs and other specialists such that they can help us to continue to improve our services, including DMS and others. So I have one more question today, and that is what's next? So, Amazon.com, we shut down this final Oracle database, but surely that is not the end of the story. So what's next, and how is Amazon continuing to explore our portfolio of database services and do more with them and create even better results for teams across the company?
Well, I think there are several areas. I mean, we just went through 2019 Prime Day in July. We're ready for the peak event. We processed close to 150 million orders just past 2019 Prime Day. Our market and our Prime membership is continuing to grow. So, obviously, number one mission is to continue to provide a solid, scalable database and services to keep Amazon.com open for our customers. So that's number one mission. And we are very happy to team up and partner with AWS to do that. And I believe that managed database service will get us there. And we're on the right path to scale our business globally and grow that business together. Second, I think there are different areas that we need to also focusing on. Because of this, we talked a little bit about cultural shift or the paradigm shift. I think one of the areas that our software engineers are learning is cost-aware design. What I mean by that is, before, engineers didn't really think about the cost of databases. Right? We had a dedicated hardware and DBAs who provision and run that service in different regions. Software engineers never had to deal with the actual database capacity. The fact of the matter is the database can now provision with an API call, and they can easily go scale up or scale down, means that software engineers really need to think about how to optimize and what is the best way to design their software based on the capabilities of AWS database services. I'll give you a good example. A lot of people migrated over to Oracle to DynamoDB. Prior to DynamoDB autoscaling feature was launched, and people really did not know how to leverage that feature. So we're in the process of actually educating software engineers. There are features like autoscaling where you can actually set it up, and then when the workload is not there, you can scale down automatically, right? And then scale back up when the transaction rate increases. And because of AWS releases so many innovations and new services almost every day, it's really, really hard to keep up. So we also need to keep educating, keep training, keep understanding how to leverage the best of the best features that AWS produce to optimize our application. At last, I think because we migrated all of our databases into AWS Cloud, and now we're leveraging managed database services, integrating all these data into our data lake and be able to process, integrate for our analytic use cases, as well as leveraging all the cloud infrastructure to bring more value to our data is probably our next journey. Journey with the legacy infrastructure was constantly worrying about how am I going to store the data. Now we can think about how am I going to leverage all the data that we have for our customer.
Right. And you mentioned, AWS is constantly launching not only new services, but great new features. You mentioned autoscaling with Dynamo. There's also autoscaling on the relational side. We had Aurora Serverless launch last year, and then we also have RDS storage autoscaling. So constantly new things to learn and embrace. And I think there's going to be some new things too that we're going to hear about in a couple weeks here at reInvent in Las Vegas. And I think that's a good time to bring up. You'll be talking about this topic further at reInvent on Wednesday. So why don't you tell us a little bit, just plug your session. Sure. And tell customers what they can come learn.
So I have two sessions actually, same session, but it's about Amazon.com enterprise database migration at scale. I'm going to talk about a little bit about our history, about how Amazon.com ended up having so many Oracle databases. And then we're going to talk about some motivation, why we had to move. And then going to go specific into reference architectures, best practices, and 5 lessons learned from our experience, and then some of the benefits that we realize and we're seeing. So that whole journey is really hard to tell within an hour, but at least we can actually share more in depth about the journey that we took on. And it was a long journey, but it's possible. And if anybody like Amazon.com can migrate this many Oracle databases, it's really in the reach of any enterprise customers to do the same.
Great. All right, well, thanks, Thomas. This has been an excellent conversation. Appreciate you joining us today. Hope it's been informative for everybody who tuned in. If you'd like to learn more about how you can start your journey to AWS databases, you can head over to aws.amazon.com/databases. All right, thanks for joining.